Greetings and welcome to my channel. I am Mr. D the Science Dude, and today we'll be discussing chemistry. So what is chemistry? Put simply, chemistry is the study of matter. It's the study of the properties of matter, the changes matter can undergo, the interactions between the different types of matter, the results of these interactions, and the changes in energy that accompany these interactions. But that kind of begs the question, what is matter? Matter is stuff. It is the stuff that makes up everything around you. The chair you're sitting in, the walls that surround you, the monitor you're watching this on, the beverage that you may be drinking, the air that you're breathing. Now, you may ask, what does chemistry have to do with me? Well, whether you realize it or not, you use chemistry every day. When you fry an egg, boil water for tea, cook a steak, use a cleaner to get grease out of a shirt, light a candle, drive a car, talk on your cell phone, or wash your hair. Each one of these examples involves chemistry in one or more ways. But here's the thing. You use chemistry every day even more directly. As you sit there right now, you're making use of chemistry. Your body is in the process of digesting and metabolizing your most recent meal. Your cells are breaking down complex molecules into more basic ones to provide you with the energy to power your body. As you breathe, you have gas exchange taking place in your lungs as the oxygen you inhale bonds to the hemoglobin in your red blood cells. You have chemistry happening within you at all times. Awake or asleep, whether you intend for it to take place or not, it's happening. When did man first intentionally use chemistry? Our earliest ancestor that we think of as man, Homo erectus, first started using chemistry with intent about 1.5 and maybe even as far back as 2 million years ago, when one of these proto-humans picked up a burning branch after a wildfire or a lightning strike and used it for warmth or to fend off a predator. The next big innovation and intentional use of chemistry was cooking, which probably got its start around 800,000 years ago. Picture, if you will, a band of Homo erectus gathered around a large fire in front of a cave, staying warm on a cool night and keeping wary predators at a distance. Caveman Og is gesticulating wildly as he pantomimes his recount of the successful hunt that provided the meat that they are sharing. As he goes through his exaggerated emotions, his bloody share of the gazelle slips out of his hand and lands in the middle of the fire. He lets out a cry of dismay and despair as he forlornly looks at his meal just out of reach in the raging fire. After several attempts, he whimpers and sits there looking at his meal as it pops and sizzles. Suddenly, inspiration strikes him. He reaches behind him for one of the spears that he and his companions used in the hunt earlier in the day, and slowly manages to rescue his haunch of gazelle meat. Alas, it appears his meal is ruined. It is no longer a lovely, dripping red mass, but has taken on a brownish color and is too hot to handle. Undeterred and not about to waste the hard-earned meal, he stabs it with the spear and holds it before him. He blows on it and futilely attempts to brush off the ashes. He tentatively takes a nibble from the edge. That ain't half bad. Encouraged, he takes a bigger bite and discovers that not only does the meat taste better, it's also a heck of a lot easier to chew. Unbeknownst to him, he's also made the food easier to digest, making the nutrients more readily available. He just invented cooking, making his food better and safer for him. Cooking will eventually provide the nourishment needed for a larger brain and the furtherance of evolution that eventually leads to you and me. Probably one of the next biggest advances involving the intentional use of chemistry is smelting, the use of heat to extract metals from the ores in which they are found. Smelting was developed 7,000 to 8,000 years ago. Like the invention of cooking, it probably came about by accident. One of the earliest metals to be used by people is copper, with some of the earliest known copper items being manufactured about 8,000 years ago. The extraction of copper involved the physical removal of the free elemental copper from veins in rocks by the use of hammers, chisels, and wedges. It is believed that the discovery that you can extract copper from ores was first made in pottery kilns between 6,000 and 5,000 BCE. Kilns are ovens used to fire or harden formed clay objects. Presumably, there were some rocks containing copper ore used to line the interior of the kiln, and after firing some pots in the kiln, someone noticed that the rocks had undergone a change, and there was a solidified puddle of metallic copper at the bottom of the kiln. This led to the Copper Age, followed by the Bronze Age, and ultimately the Iron Age. Time passes, and observations of interactions continue, and experimentation ensues, until eventually we get to the time around the Middle Ages, and the development of chemistry's precursor, alchemy. Alchemy is the ancient practice that combined both chemistry and philosophy. Probably their most famous pursuit was the transmutations of one metal into another, more specifically, lead into gold. They did also seek to cure diseases using substances that they produced, making them the predecessors of today's pharmacists. The study of chemistry can be broken down into quite a number of different branches. What we will be tackling here, for the most part, and what most time is spent on in high school chemistry, is analytical chemistry, defining and understanding different aspects of the study of matter, scientific method, measuring matter, types of matter, phases of matter, properties of matter, etc., and inorganic chemistry, the study of non-carbon containing compounds, originally focusing on substances that didn't have anything to do with organisms, living things. Other branches include organic chemistry, physical chemistry, biochemistry, nuclear chemistry, neurochemistry, and many others. I'll put a link to a video in the description below that goes into the different branches in more detail. Chemistry as we know it today dates back to the late 18th century, with the acceptance of the law of conservation of mass proposed by the French chemist who we now think of as the father of modern chemistry, Antoine Laurent Lavoisier. We'll discuss Lavoisier's law and how he developed in an upcoming video. Antoine Laurent Lavoisier was born in 1743 to a well-to-do family. He was an avid and brilliant student. He initially dabbled in geology before making chemistry his life work. He recognized as early as 1764, at just 23, the importance of accurate measurement. And although there were others who saw the importance of it, it was Lavoisier's constant efforts to promote accurate measurements in the sciences that finally got through to chemists in general. He did for chemistry what Galileo, 2 centuries earlier, and Isaac Newton, a little over half a century earlier, had done for physics. This is part of the reason why he's generally considered the father of modern chemistry. Lavoisier was also very civic-minded, joining multiple boards and commissions that were intended to improve conditions for the common man. He made 2 mistakes that caused people to overlook his many efforts for and contributions to the public good. His first mistake was to invest in a firm contracted by the French government to collect taxes. His second mistake was the blackballing of a journalist who had wanted to join the French Academy of Sciences. The journalist thought himself a scientist, quite wrongly given some of his foolish ideas. When the French Revolution broke out, tax collectors were hunted down. Lavoisier, upon being arrested, claimed that he wasn't a tax collector, as he was only an administrator and never actually collected any taxes. His assertions were found to be without merit. Put on trial, and the journalist, whom he had blackballed years earlier, now a powerful leader in the revolution, accused him of all manner of ridiculous plots. Lavoisier's protestations of innocence fell upon deaf ears, and he was guillotined on May 8th of 1794. 2 months later, the radicals were out of power, and within 2 years, the French, recognizing their loss, were unveiling statues of Lavoisier. Thank you for watching my video. I hope you found it both informative and interesting. If you did, please smash that like button below and consider subscribing and hitting the notification bell so you know when my next video comes out. When it does, please join me again. Until then, be good, be careful, and don't trust atoms. They make things up.